One good day pre-algebra. We are continuing working through CO14, a rare Friday lesson, but this is just too much fun to save until Monday, so we're going to talk about it today. These are real world situations of when you might have an expression and you want to plug values into it to see what you get. The top part of this page, which we worked on yesterday and you had homework on, was basically me giving you values for variables in an expression, you plugging them in and then you solving. Here's situations where you'd actually kind of use this concept. Graphs are something that we're going to talk about a lot in pre-algebra next year in algebra, because what are graphs used for? What are the different functions of a graph? Cade, plotting stuff. Why though? Why would we bother to plot values on a coordinate plane? What does that do for us? Yeah, go ahead. Sure, it helps us to represent data a different way. We can kind of visualize what's going on here. We can look for patterns. We can look for trends. We can predict things. We can see what's happened in the past, right? Graphs are just a really great way to represent data, all right? So here's the situation. You want to save up to buy an iPhone. Are iPhones still a thing? Yeah, they're like 13 now, right? Is that coming out next? 13. It's already out? See, boys, I always said that I would finally get a smartphone when the iPhone, Dayton, was a perfect square. So I was planning on the iPhone 9, but then they skipped it. They went from 8 to X, which is 10, right? So now iPhone 16, I want to be all over that one. But 13, that's not. Yeah, I actually, yeah. Shh, not asking you. Quiet, please.
I can't remember what my dad told me something about with Microsoft.
Yeah.
Because they skipped 9 because like something with like the programming and the numbers was wrong. So then the Apple decided to skip 9 too.
Okay, Annie, what do you know?
I think it's because.
Well, you think or you know?
No,
I'm pretty sure.
Okay.
I'm pretty sure it's because it was going to be Apple's 10th anniversary, so they skipped the iPhone 11.
Apple's been around since the 70s.
Yeah, like since they've been making like actual phones.
Oh, okay. Camille? Because 7, 8, 9. That's the best explanation I've ever heard, actually. Okay, anyway, 3, 2, 1, you are quiet. You want to save up and decide put $3 each day into, Tony, warning for you, I counted down. Put $3 each day into savings. How much will you have saved on day 5, day 8, and day 12, right? So what we want to do here is we want to write an expression that represents the situation. Cade, what do you think?
Can't you just multiply 3 by 5, then by 8, then by 12?
Yes, you can. And actually, that's where our expression comes from, right? If we're looking at this and Cade says, well, this is kind of easy for me. All I have to do is multiply 3 by 5, 3 by 8, 3 by 12. This 3 is always going to be in the expression, right? That is how much money you're putting in each day. What changes, though? First it's 5, then it's 8, then it's 12. What changes, Abby?
Like how much is
The total, right? The total saved will change. That's kind of our result. But what in the expression is going to change? Wyatt? The days. And then, so the days, can we put a number in for that, in for our expression, or should we represent it with more a variable? It should be a variable, right? Because in the expression, that's what changes. So our expression is going to be as simple as 3D, where D represents the number of days. As Cade said, he's going to plug in and multiply 3 by 5 for day 5. How much will he have saved total on day 5? 15. Okay. Then he's going to plug in 8 and take 3 times 8. How much will we have saved then? 24. All right, sorry for the dead air. 3 times 8, 24. We'll have save a total of $24 on and 3/8. Then Cade says, well, then I'm just going to plug in 12 and multiply 3 by 12 and save a total of 36. Right? So essentially what we're doing here is similar to what we did up at the top, where I gave you an expression, or this time we wrote it, right, 3D, and we're plugging in different values for that variable to get a new total. Good so far? All right. Kate, it is distracting, and it's just distracting when you blurt out questions like that too. It's those side conversations that we talk about all the time that just got to stop. Okay? And then now our next piece is to graph this. We're going to represent this so we don't have to keep plugging things in. We can kind of look for a trend. And so our x-axis here is going to be the day. And our y-axis here, we can label as the total saved. Okay, total saved. Is it going to make a lot of sense? Well, let me put this. How should we increment our x-axis here? Should we count by ones, count by twos, count by threes, count by fours? What makes the most sense here? Tony? Why 3? Again, we're talking about the x-axis here, which means, you know, what we're talking about, we're going to have to plot day 5, plot day 8, plot day 12. What makes the most sense to count by? Jeffrey, what do you think? 5? Okay. Camille? 2s? I would say we should count by 1s. Okay? Because if we count by 3s, you know, don't write this part down, but if we count by 3s, we go 3, 6, 9, 12. I mean, 5 is going to be difficult to plot in there, right? It's between 3 and 6. You know, 8 isn't exactly on there. 12 is, but we're not really counting by 3s for the days, so we wouldn't want to count by 3s on our coordinate planes. Counting by 5s, similar situation. You know, our data is going to be really squished together, and 8 and 12 aren't multiples of 5, so they're not going to land perfectly. 2s would be okay, but we do have odd numbers to deal with too, so I think 1s would be best. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Well, that's convenient. Goes out to 20. Very good. Now, if you don't want to write every number, that's a different situation. If you want to count by 2s, you know, and skip a line, so you're only writing 2, 4, 6, 8, but you still have a line for the 1, that would still work out. If your numbers, you don't want to get them too squished here, okay? How about the y-axis? What do you think we should count by for the y-axis? Keeping in mind that, you know, we're already up to 36 as a data point here. Cade? 4? Sophie? 3s? Kylie? I like 3s because how are our values increasing? It's going up by 3 every single day, right? 15, 24, 36, they're all multiples of 3s. Okay? So start at 3, and then 6, 9, 12, 15, 18, 21, 24, 27, 30, and so on. You should make it all the way up to 60? Yes. Okay? 20 lines going across, 20 lines going up. It's almost like I planned it. Almost, no, I certainly didn't, but almost like I did. Yeah, 60 is that very top line. I kind of got off there a little bit, but and then our ordered pairs, what we're plotting comes from our day and our total, right? On day 5, we have a total of $15 saved. So we're going to go to 5:15 on our graph, and we're going to plot a point. There it is. 5:15. On day 8, which was the next value we plugged in, we saved a total of 24. So our next ordered pair, day 8, $24 saved. 824 is going to be right about there. And then day 12, on day 12, we saved $36. So 1236. Okay? Plot that point. 1236 going to be right about there. And there we have it. Okay.
Don't we have to connect the dots?
Ah,
Doesn't it have to be like super straight line though?
confession time. I'm really bad at drawing straight lines. Back in kindergarten, I went on vacation for a week and I missed the whole connect the dot unit. And so now I'm just horrible at it. But yeah, what we can do now is we can connect these dots in a sort of line. Well, that was actually pretty good. Look at that.
I have 3 lines on mine.
Yeah, excellent. And what this allows us to do is to predict things. How much money will we save on day 16? Jeffrey, how much money will we have saved on day 16? Some of you might be pulling out your calculators and saying, well, I'm going to multiply 3 by 16. But what else could we do? Now that we've got the graph, what can we do, Abby? We can look at day 16 and we can follow it up to where it lands on the graph. And because of my super straight line, it lands exactly at $48. That's what graphs allow us to do. We can stop the calculation and we can just look. Okay? On what day, how long will it take us to save $42? How long will it take us to save $42, Tony? How long will it take us to save $42? Well, total saved is our y-axis, right? So we look at 42, and we see how long it'll take us. Where does this hit the graph? Day 14. Okay? The advantage of graphing data is that we have now a very good visual. We can look at it, we can solve, we can answer multiple questions without having to calculate. Cade.
So would the total save be $6?
What's that?
Would the total save be $36?
On day 15 or on day 12, yes. If we're asking about day 20, it'd be a different total saved, right? Because we're saving longer. Okay? Questions on this? Okay, yes, Quentin. Quickly. The next couple I'm going to have you do for homework. Okay, we've got 2 of them. The first situation says, your parents give you and your sister points for each chore completed. And today, in the spirit of Christmas, they're going to double the total points earned. Before doubling, your sister earned 7 points. How many total points will the 2 of you have if you earn 3 points before the doubling, or 10 points, or 15 points? I'm going to help you write the expression for this. Okay? Essentially, what's happening here is your parents are adding your sister's and yours points together and then doubling that. Your sister has earned 7 points. That's done. That won't change. What can change here is how many points you're earning. So what do you think our expression is going to be to show that you're adding your points to your sister's 7 points and then doubling that sum? Cade? Not 7 times 3. Where's the 3 come from? The first one that you're plugging in when you earn 3 points? Remember that they're adding those points together and then doubling it. So normally, if you earn 3 points, you'd have 10, right? 3 plus 7. But in the spirit of Christmas, your parents are doubling it, so you actually get 20, right? So what expression shows adding your points together and then doubling that? Kylie? Okay. And we're going to use a variable for your points. We'll use P for points, right? Because your point total changes. It says, what if you earn 3? How about 10? How about 15? So that's what changes. That's our variable. And then we are going to be doubling that. Why do we need parentheses around the adding there, the 3 plus p? Jack?
Because with the PERMDAS,
Mm.
you have to do p, or you'd have to do p times 2 first.
Right.
But in this situation, you get the wrong answer. So
Right.
You have to get the correct answer, you have to do 3 plus p to get it, and then 2 times p plus 3, whatever.
Yeah, we have to add first, right? Basically, we have to combine your points with your sister's points and then double them. So the parentheses here are necessary because we are breaking the order of operations. So just the first one here to help you out a little bit. If you earn, it shouldn't be 3 plus p. It should be 7. I'm sorry. Your sister earned 7. I had 3 on the brain there. 7 plus p times 2. Okay, you're earning 3 the first point. So the first equation that you're solving, your sister's 7 plus your 3, and then doubling it, how many points have you two earned together? 20. Okay. What ordered pair are you plotting on the coordinate plane for this? What ordered pair are you plotting on the coordinate plane? Not 220. What was our variable? So what are you plotting on the coordinate plane, Annie?
22.
Nope. Camille? 320 is the first ordered pair that you are plotting, right? Because when you earned 3 points, the total points was 20. Okay? The next one. How many total points are earned if you earn 10 points? Right? Look at what changed. That variable p, which represents your point total, that's what changed. Everything else stayed the same. How many total points have you earned now, you and your sister together? Liam? 34. What's the ordered pair that you're plotting on the coordinate plane for this? Not 334, 1034, right? 1034. Okay? The last one. How many total points if you earned 15? Again, look at what changed. That variable, right? How many total points were earned if you earned 15? Cade? Not 154. Wyatt?
15 and 44.
So 44, right? 7 plus 15 is 22. 22 times 2 is 44. And the ordered pair that's being plotted is 1544 because the 15 is what changed. That's our x-axis, right? The 44 is how many total points were earned. So now when you graph this, your job is to figure out what should you count by, right? Look at your values here, 20, 34, 44, 3, 10, 15. How do you want to incrementalize your coordinate plane? Kind of like we had to decide that on the previous one. Okay? The second one is going to be more independent for you to do, or your last one here. It says you're starting to train for a marathon. You can already run 3 miles. And beginning on day 1 of the program, you'll begin to increase the distance you run by 1/4 of a mile each day. How far will you run on day 4, day 28, day 64? Because we're running low on time here, I'm going to give you the expression. Your variable is the day again, right? Because that's what changes there. Okay? You can represent this. You are increasing your total by 1/4 of a mile each day. You can already run 3 of them. And then you're increasing that 3 by 1/4 of a mile per day. So 3 plus 1/4 times d. Your first expression is going to look like 3 plus 1/4 times 4, right? Because day 4. Then you've solved that. Your next one, day 28 and day 64. Okay, and then graph it. So see what you can do. We've got one completely done as an example, one halfway done as a further example, and now this. Homework for Monday, folks. That's how you math.